Right, hello everyone and welcome to Coffee and Code. With us today to talk about Kubernetes is Linus Östberg from the Data Center. So without further ado, I will hand over to you, Linus, and thank you very much for joining us today.
Thank you.
Right, hello everyone and welcome to Coffee and Code. With us today to talk about Kubernetes is Linus Östberg from the Data Center. So
I will do a few changes here. So let's start this one then. Introduction to Kubernetes. So as you can guess from the title, I will talk about Kubernetes, and it will be quite basic level. So the first question you can have is just, what is Kubernetes? It's a system for container orchestration, which is, well, as it says, you have containers and you kind of want to set up an orchestra. You want to know what is running where. And that's what Kubernetes can do for you. Kubernetes itself originates from Google, from the Borg system that they use to handle containers. And if you search for Kubernetes online, you're going to find the abbreviation K8S everywhere. And that one is simply based on that it's Kubernetes is K, 8 letters, and S. So K8S. So containers. Well, containers are like an environment running operating system. I think most of you have used these before. It's not a virtual machine since you don't have any abstracted hardware or anything. You only have a namespaces inside the kernel. So all the processes, network interfaces, file systems, etc., will only see whatever is in the same namespace. And the most common system for running containers nowadays is Docker, I think at least. And if you want to create a container or add an image for containers, you can in Docker just make a Docker file, and you have your from whatever as you run some commands, and then you just you start with some image, you run some commands, and then you get another image. So with Kubernetes, if you are using Kubernetes, you're going to find that you will use the command kube control. And the commands are listed here: help, apply, delete, get, and describe. They are actually covering most of the things you need to do with Kubernetes if you don't do anything super advanced. And one phrase that has been showing up very often when looking at different Kubernetes things is the phrase def by YAML, because everything is going to be in YAML. For example, in this case, we have a simple YAML file with a pod. And we have some name, we have labels, and then we define how to define it. And if you have a more advanced setup, you might get something like this, or that's bigger and bigger. So it's a lot of YAML, and you're going to really get used to YAML if you're not used to it before, if you use Kubernetes. So inside Kubernetes, apart from these namespaces in the kernel that use containers, and Kubernetes itself also has namespaces, but it mainly uses them as a kind of internal grouping. You have mainly access and resource control. I mean, who should be allowed to work with these containers, and how much resources should be allowed to use them, how much CPU, how much RAM. And this namespace is also kind of involved in this, in looking at DNS, because if you set up services, you will find that they have this service.namespace.sec.cluster.local as the general URL, and that means that if things are in the same namespace, they will be able to see each other. So time to the actual things inside Kubernetes. So as I said, we are running containers, and the containers will be running in pods. So the pods is kind of the basic unit when you're looking at anything with Kubernetes. And each pod can contain one or more containers. And the main thing of these pods is that if you start a pod and then you stop it or delete it, it will not come back. It just is something running, and then you remove it, and that's it. It might not sound so surprising right now, but you will find a bit later in this presentation that this is often not what you want. So what is an actual pod? Well, if we look at the actual YAML file, it would look like the one I showed before. You have your definition. You have an API version. Well, it's a pod. You have some metadata. You have a name, because everything here has names. But then you have some labels, and I will get back to those because they are actually quite important if you start looking at interacting with other pods, or just generally interacting with this pod. And then we have general specification. You have your containers you want to run. You have a name. It's just an internal name for the container. You have what image you want to use and whatever ports you want to use. Simple enough. And if you want to run this one, the only thing you do is then this kubectl apply -f pod.yaml. And now you see that it has created it. So we can again use this kubectl command, kubectl get pods. And now we can see that, yes, we have one pod running called menu frontend. It's one out of one pods already. It's running, and it's been running with this time, and it just never restarted. You can also get a bit more information. If you run get pods -o wide, then you also get things like internal IP, which node is it running on, etc. And finally, you also have another command that is describe. And with this one, you get a lot more information about this pod. You can see that, yeah, it's running in this lost B namespace. It's called this way, this IP. It has based on this image, got these ports open, running, and also the general events that happened. Like it was assigned to the node, it downloaded the image, and it created a container. So all this information you can get with this kubectl get and kubectl describe commands. Okay, so we have pods for actually running containers inside the Kubernetes. But if you have a pod and you have a container, often you also want some kind of persistency, right? You want to have some kind of persistent storage because you don't want to lose the files every time you restart it. For example, if you have a database, it's not really optimal if you have to restart it and again, start over from the database every time you restart it, because what's the point of having a database in that case? So for handling this, we have persistent volumes, and we have storage classes, which is kind of just base level of handling storage in Kubernetes. This persistent volume is just kind of referring to like, yeah, this data may be stored in this location. We can give it like a file path or NFS share or something like that. And with the storage class, it's more like a storage pool that you have. You have a pool of storage. You're saying, in this place we have 200 gigabytes of storage, and anyone who wants storage can come and request from this pool that can we please get this stuff. But these ones are kind of the base level in Kubernetes. This is where you define your storage. But if you actually want to use it inside a pod, you're going to need a claim, a persistent volume claim. So these persistent volume claims then will then refer to, okay, this pod is this claim is going to use 10 gigabyte, and it will use this storage class here. So the storage will come from this storage class. And these ones are not namespace; they're kind of global in the whole Kubernetes. But since these ones are referring to, it can be used in different pods and so on, they are namespaced. The reason we have it this way is because, say that you have two different clusters, and if you define this persistent volume, and then you need to define exactly what path you want to look at. And if you then change to another cluster, and you want to run exactly the same pod, well, if you had defined these things down to the volume level, then you need to rewrite everything and say that, no, I want to use this folder instead, and and then you have to modify the file whenever you move to a new cluster. But if you use a claim, and for example have a storage class, then you can just say that, okay, this claim is looking for this storage class, and if a storage class with that name exists in both clusters, then just you can just use exactly the same YAML definition for both of them. Sorry, I'm going to get the water. And if you, and if you want to look at how those look like, they look very similar to the pods and so on. It should be volumes. You have to define it in YAML. So with the persistent volume, you would then define, for example, this case, that here's my NFS share. You should refer to this path on this NFS share at this server. And then with the claim, you would then just say that I want my, you see the selector over here. I want my claim to match the label storage in the Cloud DB data. So up here, define storage Nextcloud DB data. So in the claim, you just refer to whatever labels the actual volume is using. And apart from persistent storage, you might also want to set some, partly add configuration files or configuration values to your containers, or generally as environment variables. And the way to do that is using the env keyword inside the YAML file. And for storing the information, you can also use config maps and secrets. If you just listen to those, you can see the config map is about, well, mapping configurations. And secrets might sound like it's some special encrypted thing, but it's not. It's just obfuscated using base64. So secrets and config maps are very similar, but secrets are obfuscated, but not encrypted. It's very, very important to know that. So you can use these config map secrets as environment variables, arguments, or you can even mount them as files inside your containers. I will show an example of how to do this at the end of this presentation. And again, just quickly showing how it looks like in a file. So this is a simple config map. You can see here again, kind config map, the namespace, and then you have a couple of values. You have DB host should be this, and admin user should be this, and domain should be this, and so on. And what you see here is actually, if you want to add a file, you can do it like this. Start by having a pipe, and then you just write all the rows you want to have inside this file. Okay, so we have pods. We can have persistent storage using volumes, and we can have config variables using config maps. But okay, so now we have pods. We have something. We can get something running inside the cluster. But the question is, if you have two different pods and you want those to interact with each other, how do you do that? And either you can try to look for your IP and try to connect that way, or you can set up a so-called service. The service is simply another type of entity that will use labels to identify pods. And let's say the point of having a service is to allow easy access to groups of pods. And you can also say you select these pods using labels. You can also use services to actually expose your pods directly to external access. For example, using so-called node port and load balancer. I will not really talk about this now, but it is possible. With a node port, you simply open a port on your node, and if anyone connected to that node, that port will then connect directly to the pod. And with load balancers that you can connect to, for example, if you have using it on the cloud, you can connect to the load balancers on the cloud provider, and access your pods that way. And again, if we look at what this looks like in the system, we have this service file. It looks very similar to the others. As again, kind service. You can add some labels and name, and then you can define different ports. Saying, for example, that they should connect to port 80 and the project port is 80. And then you have the selector row. The selector row is looking at the labels. So remember in the case of the pod, I had this label ID menu frontend. And now you see here in the selector, in the service, I have just taken exactly that label. So if we activate this one with this kube control apply -f service, we create the service, and then we can just quickly do this kube control get service. And you have like my information here. But if we do a describe on this one, we see that, yeah, we have this general information about it. And then we see a row called endpoints. This will be a list of all pods that this service has identified as matching. It's label it's looking for. And again, if we look at our pod we created earlier, we can just get pod wide. You see that this IP number for this pod is matching the endpoint here in the service. So as I said, the service will identify the pods that is matching this label it's looking for. And then if you want to connect to any of those pods from some other pod, you will just, if you are in the same namespace, you can ask it to connect to this service name. So say that you're running some Python thing and you want to connect the database, then you say the connect and host is this menu service, and you will connect to the pod that this one is matching. Okay. So again, services are all about finding pods and kind of creating an easy way of accessing pods. Apart from just accessing the pods internally, you might also want to have a just standard HTTP access to reach them. And for that, we have something called ingress. So again, the ingress is handling the HTTPS access to containers. This is an interface or a protocol. It's not an actual implementation of Kubernetes. It's just a kind of protocol describing how it should work, but there is actually no official of ingress. Instead, you can use multiple different ones. You can use, for example, the ones from different cloud providers, like Google Cloud Engine or the one from Amazon Web Services. You can traffic, you can use Nginx, and there's multiple others available as well. So in this case, it's more a protocol, and then you have to choose which one you want to use. Connected to this is also a program called Cert Manager. This is not part of the standard Kubernetes, but I really recommend getting it because it helps with the certificate. I have really written wrong with this one. It's with certificate management. And you can also integrate it directly with Let's Encrypt. So you just have that, okay, now I set up something to listen here, and it will automatically create a certificate for your service. It's really useful to have. So if we again go back to command line and we look for this ingress file. So this is an ingress file. And here you can see on this API version row that I have two different ones here. One is commented and one is not. It's because that on this cluster, we are running Kubernetes 1.18. And there, this one is called version 1 beta 1. But if you are running Kubernetes 1.19 on your cluster, it will still be called version 1 because now it's no longer in beta. So you just choose whatever version, depending on what version of Kubernetes you have. So again, we have an ingress. Oops. We have some metadata. We have this name again, always a name. And then we have some annotations that we use for this ingress. In this case, I'm just telling it I want to use Nginx. And then I have the cert manager. We have set up a cert manager issuer to connect it to Let's Encrypt. And then we have specification. And this TLS part here, that's for the certificate that you define what host you want to Let's Encrypt to generate a certificate for you for. And then you just give it a name to save it. And here we have the actual rules. So you have your host, you have it's going to access on path route, and it's going to connect to the service called menu service on port 80. So close that one, and then we just do a kube control, apply F on that one. Can do again, just kube control. Can we go directly to get ingress. So quickly on this one, you can see that, yeah, it has the host here for this coffee.usdcube.sciliflab.se, of course 80, and it's called that. And again, if we do this describe ingress, we see some comments about setting it up and creating a certificate down here on the events part. Up here, however, we can see that the addresses, and then you have this part. Do you recognize this IP? This is the IP of the pod, right? So yeah, I saw a comment about there's a dog barking, and it very well could be because we have a dog living upstairs. We have a family with a dog upstairs. So it might very well be that we have a dog barking now and then. Anyway, so this IP you have here, that one is once again the pod. So the fact that we have the ingress is connecting to the service, this menu service, and the menu service is then connected to the pod. So this way we have the full connection from the HTTP, the ingress all the way down to the pod. And if we want to test if this actually works, we can run to my web browser. And the thing I created here with this pod originally was the front end for the menu page. So here you see we have an empty front end for the menu page running. And most of all, we have a certificate because the cert manager automatically created a certificate for us. So we have everything we want to run up and running here. So in order to get the actual web page up and running, you need to create a pod, service and ingress, and then you can actually have everything up and running. But then comes the second thing here that, okay, so we have this pod. But if the pod is crashing, or say that we have multiple nodes in our cluster and one node goes down, this node will not restart. It was only running on this specific node, the pod will not restart. It was only running on that specific node, and if it crashes, it's gone. So in order to handle this kind of making sure that it always is a pod running somewhere in this cluster, we can use something called a replica set. So the replica set is, again, you have to find a number of replicas for the pod. And once more, let's say define replication of pods, and it will start and stop pods to match the wanted number of replicates. So again, I will go back to command line. We will look at a replica set. It's again, this part, I think you all, which is the top part here, I think you all got used to by now. Again, we have the selector, we have match labels. And this means that the replica set will check for these labels to tell if there's enough correct number of pods running. So you want to make sure that these ones are unique. These labels together should be unique. There shouldn't be other things running with these labels. Because if it is, then the replica set will believe that they're part of what they should control and control those as well. And in this case, I'm asking for 5 replicas. Should be 5 copies of the pod running. And then you define a template. Define template, and this part here will look more or less exactly like the things we were having before. We have this metadata, just like with pod. We have labels, and we have our specification. So kind of from here, it's more or less exactly like in the pod definition. Yes, it's a bit indented. Again, image. So if we start this one, Q control apply F replica set. Again, you see it's created. You can do a control get RS. So we have this replica set running. And if we look at pods, now we have a pile of pods running, right? This is the original one created. But now you see I had this menu RS and then a small hash. These are the pods created by our replica set. And say now that we released some service and suddenly this service became extremely popular. So we want to have more pods running that can handle the traffic. We can then simply modify our replica set. Go here, we say replicas 10, for example. Then we just run kube control apply again. And now you see it's set configured. So it simply means that now it's not created as it was before. Now it's actually just modified on the one we had running. And if we check pods again, you can get pods. Now we have 10 pods running, right? We have 10 different pods running because it's replica set. And say then that, okay, the service suddenly became extremely unpopular, but we still want it running. So say that we only want 2 copies instead. Again, we just apply it and we check. And now you see there's multiple copies comments about here about terminating. And then we check again. And now you see that we have 3 pods running in total. 2 of them are from the replica set, and 1 of them is the original one we had. So with the replica set, we can just define exactly how many copies we want of our pod. And also it's that if we now say that we want to, one of these pods are in a node that just crashed. So we can just delete it. Delete pod. That was the wrong one. So now we delete the pod. And we can do cut pods. So before we had this CFWBD running, and now that one is gone. We still have this WBR9, but you see that the replica set immediately starts a new pod. And you can see that only running for 4 seconds. So if some pod is crashing, it will immediately just be replaced by a new one by the replica set. So replica set seems to handle all this stuff quite nicely. But it does have kind of one big weakness, is that if you want to upgrade, say that you have you released version B of your software. And right, should apply it. Sorry. Control apply F. But you see, nothing changed. We still have exactly the same pods running. Nothing has changed at all. And if we look at these things, we can see that kubectl get pod. We say we want to look at this one. Sorry, just describe instead. We can quickly see here that if we look at the labels, this one still has its version A, not version B. Because the replica set does not kind of nicely replace the old ones running the original version. Instead, they will keep on running, and they will be replaced once a new one is starting. So if I, for example, would modify this replica set again and ask it to have more replicates. Sorry. Well, we have more running. But if we look at one of the new ones, they are running version B. But we still have all the original version A running as well. So it means that this replica set doesn't really have a good way of upgrading your existing pods to the new version. And that's where we come to the next part of the presentation, which is talking about deployments. So the deployment is kind of controlling replica sets. So it defines how to run the replica sets, and it allows progressive deployment of new containers, meaning that, for example, in this upgrade case, it can actually handle it nicely and upgrade all the running pods. So now we are going to look at this deployment. It looks very close to how the replica set looked like. We have, once again, just deployment. We have this selector. We have replicas. We have this template. You can see that I added a small thing called readiness probe here. It's simply a check to confirm that everything is running correctly on the pod. In this case, it's simply checking if the pod is responding on port 80 on the root path. Then it will say that, okay, this container is ready to be used. So if we apply this one, now we're going to have a lot of pods. So we have the original pod, we have this replica set pods, and now we have the deployment pods. So you can see we have the name of the deployment, we have a hash for the replica set it creates, and then we have a hash from the replica set to define the pod. You can see that all of these ones are creating, and now they're all running. Okay, so now we think that we want to do this upgrade. We want to change to version B instead. We upgrade, we change the YAML file, we apply it, and then we do like this. And now we can see here that it's slowly terminating some of the containers that we're running, and we're starting them, and then starting them with a new one. So it's now terminating a few more because the new ones are working. So we start the new ones, it's terminating the old ones, and starting the new ones, and so on. So it will remove a couple of the old ones at a time, and check that, okay, we got the new one up and running, and then we delete a few more, and a few more up and running. Okay, we delete a few more until it's done replacing all of the containers we had running. So if you look at these old ones from replica set, you can see that they're all from the same time. Well, if you look at these ones from deployment, they all have kind of staggered time start time. They're starting at different time because it's just replacing a few of them at a time. So that simply means that if we want to deploy things and actually have a nice way of deploying it in reality, we should probably use deployments rather than replica sets. So deployments are kind of the standard way of deploying whatever software you want to run. You can set up a pod if you just want something very temporarily, but if you want something to run over time and have a good uptime and so on, then you want to run a deployment instead. Other useful things that I think is worth mentioning in regard to Kubernetes is, well, again, this insert manager I mentioned, set up together with Ingress to have the easy access to, automated setup of Let's Encrypt, for example. It's worth looking into this readiness probe to make sure they have a good way of telling if the new setup worked. Because if you don't define a readiness probe, then the Kubernetes will just think that, okay, yeah, this one didn't crash, so it means that it's ready to handle things. But with the readiness probe, you can set up things to confirm that it's actually doing what it's supposed to do before you say it's ready. And with deployments, for example, you have that if the Kubernetes doesn't think it's ready, then it will not terminate the existing ones. It will wait until the new one is ready before it starts terminating more pods. Another thing that is really worth looking into is called Customize. It's a kind of automated, but a simple way of generating config maps and secrets, etc., for using just for example, a config file. I will show you an example of this. There's also something called stateful set to kind of make deployment replica sets, etc., have a stable name without all these hashes. They will just have a standard name with just 0, 1, 2, 3, etc. And finally, I recommend looking into Helm, which is kind of what's called Helm charts, simply kind of descriptions of how to apply. It's a combination of different YAML files describing how to set up a certain service. For example, if you want to set up a database, you can probably just look for Helm chart describing this database and set up a few values, and then you have it up and running rather than have to write this YAML file from scratch. So I have one more thing I intend to show off. It's some actual bigger setups. So I thought to start off with this, that we have this menu. It's a complete setup of the menu page. So we have a deployment, some metadata, some labels, etc. In this case, I'm just running one replica. There's the version number. And here you can see that I have containers. And I have first one container. I have some resource description, so how much resource is allowed to use. I have some ports. Here we have this thing with env that you can use a definition. If you want to set the environment variable, you can just do it like this. We had the readiness probe to confirm that it's ready. And now you see in this one, I actually also had a backend running in the same pod. So I have both the front end and the backend running in the same pod. This is often not really a good idea, because if you want to scale or something, you will need to scale them together. Say for example, that the front end is completely overloaded, but the backend is fine, or vice versa. If you set up both containers in the same pod, then you have to scale at the pod level, meaning that whenever you want an extra backend, you have to get an extra front end as well. So it might be a good idea to split them into two. But I thought in this case, just so easy to just put both containers in the same pod. And then so we have some ports. We have with another readiness probe for this container. And then again, we have a service. Just like the other ones. Here I have two ports, one for the front end, one for the back end. And also have, again, this ingress file defining that this thing should be set up on the coffee menu.tcq/SciLifeLab.se address. And finally, I have a new thing that you haven't really seen, is that this is how we define a namespace. It's also just a simple YAML file, kind, namespace, a name and label, and that's it. And now if you want to apply all of these things together, you can actually just run kubectl apply-f dot. And now we start everything in this folder. So if we now go to this URL, it was coffee menu. So this is how it looks like if you don't have anything running. But here we have a complete setup of the menu page. Just set up by running kubectl apply-f in one folder. And we have everything up and running. So this is how the menu page is actually running in reality. I just have this simple folder prepared with all the YAML files, and we just run it and up and running. And one more case, which is a bit more complex. We go to this DSW instead. In this case, I'm using, as you can see, that I have a file here called customization.yaml. So customization.yaml is connected to this customize I mentioned. It looks like this, like generator options, We have a secret generator to generate secrets. We have a config map generator to generate configs. And then it's defining kind of like namespace, env, and so on. So it's kind of, this is different files that it's talking about. And this, for example, conf rabbit.txt looks just like this. So if you use this env, if you're going to look for a folder like this and then just create a config map or secret where username, the value of username would be equal to rabbit and the password would be equal to rabbit password and so on. And we also have this other thing called files, which means that there will be an actual config file. This is the config file for that one. So it's just a standard config file in YAML, but it could be any language, it's just a file. And then you just define it like this, like files. And then you say what name the config map should have, what namespace should be put in, and so on. And then if you want to generate all these config maps and so on, then you just run apply-k dot. Right. I need to do one more thing before I can run that. I need to actually create a namespace. And now we created all these config maps and so on just based on the definitions in this customization file. So instead of having create a config map file where I define all these things and have perfect formatting, etc., I can just take the use this customization. I use my original config files and then run this one to automatically create the correct config map. And then we can look at the deployment. So this is quite a big deployment. It's actually a small part of this one is actually the long example I was showing in the presentation as a long YAML file. So we have all these things. Then I'm actually going to look at things down here. There's a volume mounts. So this is about mounting things inside the system. And you can see here that I'm saying that you can start the volumes. In this case, I'm saying that I want to create a volume called serverconf, and I want the volume to be a config map, and the config map should then have this name. So in this case, I'm actually using this config map setup. I mean, the config map I created as a volume, and then I'm telling the system to that. Okay, I want to mount from this volume I have mentioned down there. I want to mount this path, and I want to mount this specific part of it. So this test application YML, that one is just kind of like a value inside the config map. And it's just saying that I want to mount this one as a file at this location. And if we go down a bit further, you can also see it from another config map that you can also use your config map directly with this env. And then you say, okay, the environment variable is called this way. And then you say that the value should come from this config map called this way, and you use this key. So config map setter, you can either mount them directly as files, or you can use them as variable values inside the config. So you can do them both ways. I can also show you quickly take Mongo, for example. Down a bit. Down here, we have this. We have a persistent volume, and we have a persistent volume claim. And this one is called DSV Mongo storage. And if we go up to our file here, we can see that we have a volumes defined down here. It's saying use this DSV. Oh, come on. DSV Mongo storage. It should be a persistent volume claim with this name. So it works exactly the same as if you have a config map as well here. Just in this case, it's saying that it's a persistent volume claim instead of a config map. And then you can just mount it exactly like with the config map. Yeah, so again, we can just, to activate the whole thing, we can just do it like this. And this customization.yaml file is not compatible with the Kubernetes API, the Kubernetes style. So whenever you have a customization file inside your folder, it's always going to end up with a warning like this. But you saw anyway that all this stuff I set up now, we created a lot of different deployments and services and namespaces and blah, blah, blah. And in total here, check in the ingress, you can see that it's connected to this Coffee DSW. So we go to the web browser. And here's the API, and then we have the actual. Here we have a full setup of data stewardship wizard up and running. Just using just one command. It takes a while to write all these YAML files, but once those are done, the only thing you have to do is run kube control apply F, and you have the whole thing up and running. And with that, I'm actually done. So thank you for listening.
Great, thank you very much, Linus. I think we have a question here in the Zoom chat. It's from Matthias Stahl. He's wondering, what is a typical use case of Kubernetes in your daily work?
Well, in my case, it is that we are hosting a lot of things on our cluster. This cluster I showed you now is actually where we're hosting. Well, we have a Nextcloud instance running for all of SciLifeLab. We have this data stewardship wizard for all of SciLifeLab. We have this COVID-19 data portal running this one as well. We have a lot of different things running on this. So we are using Kubernetes. I mean, I'm using it almost daily just to handle all the things we are hosting.
So I guess I have a question. So when you set this up, did you look at any other tools for this, or did you just, what you ended up with?
In this case, it was more that we just started looking into it, and for me, they fell in love with Kubernetes, kind of. There might be other tools that are equally good, but Kubernetes really, well, it was really relatively easy to learn, and it's really nice to use.
Sounds cool. Right. Are there any other questions? YouTube is usually a couple of seconds behind, so, but. Right. I guess if you have any more questions, you can post them in the Slack channel. Maybe you can have a look there.
Yep, I'll do so. So thank you.
Yeah, thank you very much for today. And I guess, as usual, if anyone has anything they want to present, just get in touch. And otherwise, I guess I'll see you next month. Thank you very much, everyone, for joining.
Bye-bye.